Chapter 4, Geometry Review. The first question says, if BCDE is congruent to OPQR, then DE is congruent to DE here would be congruent to QR, which would be D. Number 2, angle ABC right here is congruent to which angle? It would be the one with N in the middle, which would be angle D. Number 3, given triangle QRS is congruent to triangle TUV, and QS is 3V plus 2, and TV is 7V minus 6, find the length of QS and TV. To do that problem, you would need to realize that QS and TV are congruent. So you would set this up as 3V plus 2 equals 7V minus 6. I would solve. I'm going to subtract 3V. 2 equals 4V minus 6. I'm going to add 6. 8 equals 4V. Divide by 4. V is 2. If V is 2, then you're going to come back in over here. You're going to plug that in. 3 times 2 plus 2. 6 plus 2 is 8. And the other one should be the same thing. 7 times 2 minus 6. 14 minus 6 is 8. That's question number 3. The lengths are 8. Justify the last two steps of the proof, given that RS is congruent to UT and that RT is congruent to US. So RS is congruent to UT and RT is congruent to US, and we know that they're congruent by reflexive, and that would be side, side, side. Number 5, based on the information, what can you conclude and why? And it says, given that angle H is congruent to angle L. Now those are congruent but not right. I drew that so it kind of looks that way, but it's not. And that HJ is congruent to JL. And we know that this little angle and this little angle are congruent by vertical angles. These are congruent by angle side angle. And it would be HIJ congruent to LKJ. Which is answer choice A. Number 6, name the theorem or postulate that lets you conclude that these are congruent. Well, you know that that's a right angle, and you know that this is congruent. However, be careful because we don't have the hypotenuse here. This is not hypotenuse leg, and it's not one of our options. It's side angle side. Number 7, supply the missing reason to complete the proof. Angle Q is congruent to angle T. QR is congruent to TR. That's all given. These are vertical angles. So now triangle PQR is congruent to SRT, or PRQ and SRT by angle side angle. And the little pieces PR are congruent to SR by CPCTC. So that is answer choice D for number 7. Number 8, R, S, and T are the vertices of one triangle. E, F, D are the vertices of another triangle. The right triangle. Measure of R is 60. Measure of S is 80. They're not right triangles. I just dreamed that up. This one doesn't say that. F is 60. D is 40. RS is 4. EF is 4. Are they congruent? Well, I need to know the missing angle. So 180 minus 80. 180 minus 80 minus 60 is 40. So it's a 40-degree angle. This is an 80-degree angle. Now let's see. I have a 60 and a 60. And between there I have these that are both 4, and then I have an 80. So I have yes by angle, side, angle. What number are we on? 8. And so RT is the 60-40 one right here, and it's congruent to FD. Number 9, find the values of X and Y. Well, okay, we got this. This is 47, so this one would also be 47 because the big triangle is isosceles. So 180 minus 47 minus 47 is 86. Now I'm going to take that and split it into 2 equal groups. So 86 divided by 2 is 43. Now you've got this triangle that's 47 and 43. 47 plus 43 is 90, which leaves this to be 90 as well. So X is 90, Y is 43. Number 9, the answer is D. 10 says, in an A-frame house, 2 congruent sides together with the ground form 34-degree angle at the peak. Okay, so these are congruent. So 180 minus 34 leaves 146 divided by 2. It's 73 degrees in either one. That answer choice is C. 11 says 2 sides of an equilateral triangle have lengths 2x and 3x minus 6. Now it's equilateral. All 3 sides are the same. So 2x minus 2 is going to equal 3x minus 6. I'm going to subtract 2x from both sides. Negative 2 equals x minus 6. I'm going to add 6. X equals 4. Okay, if x is 4, I'm going to plug it in and see what I get. 2 times 4 minus 2. 2 times 8. 2 times 4 is 8. 8 minus 2 is 6. 3 times 4 minus 6. 12 minus 6 is 6. So when I plug 4 in, I need to get 6 as an answer, and that'll be the side that is my third side. So on number 11, if I plug it in here, 10 minus 4 is 6, so 10 minus x works. Let me try the other one. 6 times 4 plus 5 is 24 plus 5 is 29. That one does not work. So the only answer for 11 is B. Number 12 says, which overlapping triangles are congruent by angle, side, angle? And that would be ADC, ADC, you got a right angle, and you've got this marking here, and EBC, EBC. Because angle C is congruent to itself. Number 13 says, write the missing reason to the proof. AB is congruent to CD. Angle A is congruent to angle D. AF is congruent to DE. So all that's given. AB is equal to CD, definition of congruent segments. AB plus BC is equal to CD plus BC. That is the addition property of equality. I'm adding the same thing to both sides. I'm adding BC to each side. Then it says that AC, this distance, is equal to BD, which is this distance, segment addition postulate. So I've got this triangle with this side and this angle that. And then I've got this triangle with this angle on this side and that. So what I have are two triangles that are congruent by side angle side. The next step is to say that AC is congruent to BD by definition of congruent segments. So my final statement here is side angle side. 14, segment BF is congruent to what, and explain why it's true. Okay. Well, we have BF is congruent to EF. In this triangle, this segment splits the vertex angle of the isosceles triangle. So it also hits the midpoint, which makes FE or EF congruent. 15 is triangle PQS congruent to RQS by HL. Well, they share this side, they share a hypotenuse, so the answer is yes. The leg that allows them to be is QS. 16, write the missing reasons to complete the flow proof. Given the angle ADB and CDA are right angles, angle A is congruent to angle C. Those are both given. At triangle ADB and triangle CDA are right triangles. How do we know that? Definition of right triangles. Then it says BA is congruent to BC because of the converse of the isosceles triangle theorem. DB is congruent to DB reflexive. The triangles are congruent by hypotenuse leg. Name a pair of triangles and state where they're congruent. Well, they tell us, I'm going to separate these triangles. MPN, MPO. They tell me that NP is congruent to OM and MN is congruent to PO. And MP is congruent to MP by reflexive, so they're congruent by the triangle, by side, 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 and triangle MNP is congruent to triangle POM. 18. Complete the proof. It says CD is congruent to DE. No, CB is congruent to DE. CB is perpendicular to BD. CB, there's a right angle there. DE is perpendicular to EC. There's a right angle there. CBD and DEC are right angles. CBD are congruent. All right triangles congruent. CD is congruent to CD, reflexive. So triangle DBC, now let me draw that over here. It's congruent to CD, CED, there's the right angle, and it would be by hypotenuse leg.